Okay, hello and welcome back. This is Ahmed for Avionics, and we are in the Mastering Docker course. This is the second section titled Hello Docker. So in this section, we're going to start exploring Docker, what it does, what it is there for, and we're going to create a sample example to get our hands dirty at the end of this section. So let's get started. Now, what is Docker, which is the most basic question that you might be asking yourself? Well, long time ago, we installed software on an OS that is installed on a particular set of hardware devices, CPU, memory, disks, etc. That was the way to install a software when you have an application and you want to test that application or deploy it. You will have to have a set of hardware devices inside a hardware computer or server, and you deploy the software on that computer. And then came virtualization technology, which is, as we explained in the previous section, the ability to run multiple OSs on the same set of hardware by distributing that hardware or abstracting it to smaller machines called virtual machines, and those virtual machines are isolated from each other. But this was still a resource-intensive process, and as we said, it still needed much time. Now, Docker fills the gap between having to run totally separate OSs, like on a virtual machine, to run a software application, and running that application directly on the same OS, however, in an isolated environment. So the problem that Docker tries to solve is how to install or deploy a software in an isolated environment on the same OS that you are using without having to install or deploy a separate virtual machine to test that application. And further, how to deploy multiple software in multiple environments on the same machine without having to install or deploy separate virtual machines for those environments. This is where Docker comes into play. Docker creates a lightweight level of virtualization using containers, and we're going to discuss containers in the next slide. Docker is an open source Linux-based software that can run on any hardware environment that supports it. So we have Windows, Linux, Mac OS X, all of those support Docker. So you can run the software on Linux and port that software or ship it using Docker to any hardware that runs any operating system like Windows, Linux, or Mac OS X, and it will run exactly the same way it ran on the machine that you developed it on. Let's see how this is done. As we said, Docker uses containers, but what are containers? Containers are not something new. They are not invented by Docker. They are not a new term. They are as old as Unix itself. Since the old days of Unix, system administrators used jails to isolate processes in closed environments. And by closed environments, I mean a special runtime space for the process or the application to live in, where it cannot access any protected resources. That's been always a need for developers and system administrators alike. They need to create an isolated environment, a sandboxed environment for the applications to be tested without having to worry about that application misbehaving or accessing resources that it should not access or altering the operating system in some way or another. So the concept of jail was introduced long ago, since Unix start, in order to create those isolated environments for software. Then the term container was popularized by the release of Solaris 10, which was released by Sun and then purchased by Oracle, and it used Solaris containers to provide even more isolation than jails. The difference between a container and the old jail is that the jail protects some resources of the system from being accessed by the application or the process, while a container denies process access to any system resource except the ones explicitly granted to it. So that is a higher level of protection, a higher level of isolation. But the problem is that containers are complex and hard to set up. Accordingly, users either misconfigured them or simply could not use them at all. So users used virtual machines, for example, which is a resource-intensive and lengthy operation to install and deploy, as we said. But a lot of users resorted to virtualization and virtual machines instead of containers because, as we said, containers are complex to set up and hard to configure. Docker solves this problem because it uses existing container engines to build containers according to the best practices. So Docker builds the container for you. It deals with all the heavy lifting, it deals with all the hard parts of container creation, and it creates a container for you to be readily available to host your application, achieving the highest possible level of security and protection. And this process does not require any user intervention. and accordingly the result of this is putting the container technology in the reach of everyone. Now, is container a form of virtualization? Well, yes and no. A container is not a virtual machine. Okay, if you want to compare a container to a virtual machine, no, a virtual machine is a completely isolated machine with its own operating system, with its own set of resources like the CPU, the memory, the disk, and so on. It's a totally isolated machine. Okay, it's built by abstracting the necessary hardware resources to run a whole instance of an operating system, and afterwards you can install your software in that instance. But the problem with virtualization, as we said, is that a lot of resources get wasted just to run the OS instance, not just the software application. So for example, if you want to test a web application written, for example, using PHP, and you want to install it in a sandboxed environment, you may use VMware or VirtualBox to create a virtual machine and install CentOS, for example, or Ubuntu on that virtual machine. And in order for that machine to run, you supply, like, for example, 1 GB of RAM and dual core CPU and like 10 GB of disk space just to run the OS. Then after running the OS, you can start deploying the web application and start testing it. So here you have wasted about 1 GB of RAM or more just to run the OS, while the application itself may be using much less RAM than the amount you are supplying, but you supplied that amount of RAM just to get the OS up and running. Same way goes for the disk, same way goes for the CPU. But when you use Docker, it runs in an isolated environment that interfaces directly with the Linux kernel of the main OS if you're running it on Linux. If you're running it on another operating system like Windows or OS X, which is not Linux-based, then Docker creates a very small virtual machine, and this virtual machine is used to create multiple containers using the same virtual machine, which of course reduces cost and largely reduce the amount of time needed to get the container up and running. Actually, if you want to measure it, you can spend like 10 minutes to start a virtual machine and start a web application or whatever application was installed in it, while it only takes a few milliseconds for a Docker application to be up and running. So that is a lot of time that was saved. And if you want to discuss Docker containers, we have to discuss Docker images. A Docker container is where the application is physically stored together with its dependencies. A container can be thought of as a box or a ship, but a box must contain something. It must be filled with something to be useful, and this filler is called the image. The image fills the container, it fills the box with the needed prerequisites, the needed files and dependencies that the application needs to run correctly. An image can be used to create as many containers as needed. You can use one image to create multiple containers as much as you want. Thus, when you want to ship an application inside Docker, you ship the image, and the recipient OS or the recipient computer creates containers out of that image. It can create as much containers as it needs. It can create as much environments from that same image as it needs. And to make things even easier, images are stored in registries and indexes. Those may be publicly available on the Docker website or other hosting companies. You can also host your own indexes and registries. So in order to facilitate things, Docker has something called the registry. This registry contains a lot of ready-made images for you to download and use. Let's have a look at it. So we're going to open Firefox and search for Docker Hub. Okay, here we go, hub.docker.com. If you have a look at this website, this is the Docker web application website. Click on Explore. And as you can see here, we have a lot of images that are readily available for you to just download and use. You have a lot of well-known applications like Nginx, BusyBox, Ubuntu, MongoDB, MySQLDB, Postgres, Node, and others. You can pull any of those images and use them to create an isolated environment for whatever application you need to use. And that brings us to the end of this lecture. My name is Ahmed, and see you next.